Now we're going to work in the opposite direction. What if we're given a graph? How do we find the equation? I'm going to be looking for those kind of key pieces and just thinking of how can we fit that to using sine or cosine, so that'll be part of our decision, but filling in our transformations for how to get that graph out. And then with these, a great idea is when you get to the end and you find that function, graph it and see if it matches up. Alright, so first thing we can do is decide whether we're using sine or cosine. So for example, with this one, I can see we're starting at the origin, then we go up to a maximum, and then go down to a minimum. This is great for using sine of x. So that has the general shape of sine. But again, sine and cosine relate so closely, so what you could notice is you could use cosine here. You would just have a phase shift. You'd have to scoot it over by 1/8. So with these, there are multiple solutions. In fact, there are infinitely many solutions because we could keep using phase shifts to get to different spots. I'm just going to go with kind of the simplest ones, but there are multiple solutions for these. Alright, what I'm going to look at is the amplitude. So the amplitude here, that distance, so we're going from 0 to 6/7. So we're seeing 6/7 there. The midline is at y equals 0. And then the period, so if I start at the origin there, go up to maximum, down to minimum, and back to the midline. So for the period, I'm looking at this distance here. So the period is equal from 0 to 1/2, so that distance is 1/2. And then I can just make a note that there's no phase shift. There's also no reflection, if you wanted to make note of that, but basically the amplitude, midline, and period are going to help us out with this one. Alright, so plugging in. I can start plugging in that this is y equals amplitude of 6/7, sine of, and b. So, if you remember, period is equal to 2 pi over b. So we have this calculation to do. So this period equals 1/2. That's the period, that's not b. So we do not put 1/2 there. Instead, we need to think about what's the number that's changing 2 pi to make it 1/2. So we have some solving to do. So just always pause with plugging in b there, because we're going to have some work to do. So we found that the period is 1/2, and that should be equal to 2 pi over b. So what we're going to do is solve for b. With the fractions, you can do this a few different ways. I like to use cross multiplication. So cross multiplication means on one side of the equation, you'll be multiplying the 2 and 2 pi. On the other side of the equation, the 1 times b. So we'll have 1 times b equals, so 1 times b on one side of the equation, and then equals 2 times 2 pi, which is 4 pi. So the value that we actually want to plug in for b is 4 pi. So just keep that in mind that when we're plugging in for our transformations, you have some calculations to do for b using the fact that you can find the period from the graph, but you need to solve for b to know what to plug in the equation. So that means b is 4 pi. There's no phase shift, so we just get to close the parentheses. However, we need a variable. So before we close the parentheses, we need our variable x, and then we can close. So very, very important. We start plugging in these values and thinking about our trig function, that we can forget our input variable. We need one. Otherwise, it's just a constant, and it would actually be graphing a horizontal line. So we need our variable. And then our midline is 0, so I don't need to add or subtract anything on, and that is done. And then we could check by plugging that into Desmos and making sure that it graphs correctly. Actually, let's do that with this one, since the axes are kind of interesting, and just show you how to get to that same spot. So, go to Desmos, and we're plugging in our 6/7. So 6/7 sine of 4, and then for pi, again, I just type in pi, and then x, and we get that whole mess. But let's say I want to set it so that the axes match what we see in our picture. So how I would do that is I would go to graph settings. Now the x-axis, let's see, that's going from -3/4 to 5/8. So I'm just going to type that in. -3/4 up to 5/8. And the steps they're using, 1 square is equal to 1/8. So it's going to show in decimals there, but it's basically setting that up. And then I'm just going to adjust the x-axis, or sorry, the y-axis, what it's going from -6/7. It's going a little beyond that. I'm going to go from -1 to +1, just see a little outside of it. And then the step they're using is 6/7. So with that, we can see 6/7, -6/7, and that's our maximum minimum values. We're starting at the origin right there. And then in terms of completing the whole period, that starts repeating at 0.5. So with that, we can check those key values coming through based on the function we found. All right, with this one, so figuring out which function we want to use. So you can see we're starting here at a minimum value, which sine and cosine both don't do that. However, what we saw with graphing are the reflections. So what we could do is cosine usually starts at the top here and then goes down. So we could use the reflection. So we could use negative cosine of x. That's a possibility. Again, we could use sine and then just have this phase shift to the right by 2 in there. Both of those will work. I'm kind of skipping the multiple ways because we're going to look at a case of forming the 2 equations down below there. So we'll look at forming both of them with phase shifts, but for this one, let's go ahead and use negative cosine since that will be simpler. And with that, let's see, we need our amplitude. So we have our midline at 0 there. So we see an amplitude of 4. Midline is at y = 0. If we're using negative cosine of x, there's no phase shift. And the period, so if we start there at the minimum, when we start to see a repeat, it's right there. So we're seeing the period equals a horizontal distance, let's see, 0 to 8. And just so you know, you can see the period in other places too, like if you did this maximum to maximum, that would be from 4 to 12. That distance is also 8. So you can see the period in multiple places on the graph. It doesn't have to be starting at the y-axis. I tend to go there because it's easiest to start counting from 0. But the period's occurring all over the place here, like 2 to 10, even whatever's happening here at 3 to 11, that's going to be a single period right there too. So you can see it multiple spots. All right, so with that, first thing I'm going to do is find b. So we found the period of 8 is equal to 2 pi over b. We could do the cross multiplication, or you could think of multiplying both sides by b. So we're going to have 8b equals 2 pi. Divide both sides by 8. So that's going to be pi over 4. So for our function, a is going to be negative, since we're using negative cosine of x. So we have a negative 4 using our amplitude. Cosine of, and b is pi over 4. And then we have our variable x. And then we close the parentheses since we're not using a phase shift. And then the midline is 0. So that's that. Alright, our last one here. What we're going to do is create two functions, both for the same graph. One's going to involve sine, one's going to involve cosine. Now, before even doing that, the amplitude, midline, and period will be the same for these. So, with that, let's go ahead and look at our values here. So, looks like some minimum values are happening here at -6, maximum values at -1. So that means halfway between those, so let's see, just so I can clearly see these increments here, we have 1, 2, 3, 4, 5. So our midline should be halfway in between there. So we have a midline at y equals -3.5. So that occurred from maximum of -1, minimum of -6, and then I was just looking at where is halfway between those two values. And then with that, I can visualize the amplitude. We went 1, 2.5. So the amplitude is 2.5. So we have those two pieces. So I'm going to go ahead and write at the top here. When we plug in, we're going to have A equals 2.5. We don't know B, we don't know C. D is... Alright, so now for the period of the graph, what you can see here is we actually can't see a full period, but we can see half of a period. And that's good enough. We can just double it. So let's see, what color do I want to use here? If we think of starting from down here to up here, that would be half of a period. So there's minimum, midline, maximum, and then it would just go midline down to minimum. But with only half, so this distance here is half of a period, which that distance is, we can count these pi/6 values. So we have 1, 2, 3, 4. So what we're seeing there is half of a period is 4 pi/6. So for a full period, we want to double that. It's twice that distance. So that's going to be 8 pi/6, which, simplify that down, 4/3. So, period is 4 pi/3. We would need to do some work in terms of changing that to b. So we know 4 pi/3 is equal to 2 pi/b. I'm going to go ahead and cross multiply. So 4 pi times b is equal to 3 times 2 pi. Divide both sides by 4 pi. So b is going to be equal to 6 divided by 4, so 3/2. Okay. So we have b is equal to 3/2. Alright, so let's start with the idea of using sine. So sine would start at the midline, and it would go up and down and back up. And where I'm seeing that behavior occur is starting right here, at this point. That would match up the behavior of sine in terms of reading to the right. We would go up and down and back up, just like sine would. So what happened is there was a phase shift, though. Sine would be beginning right here, but what we did is we had a phase shift, and the movement is going to the right. So we picked it up and moved it to the right, a distance of pi/6. So if I'm putting together sine, I would have y equals my amplitude of 2.5. I'm using my sine function. We found a value of b of 3/2. Make sure that's factored out. So then we would have x, and then our phase shift, so we're moving to the right, so that means we'd have subtraction of pi/6. and then we close those parentheses, and then close the second parentheses. And then our last piece is the midline, which is negative 3.5. So, amplitude, function sine, which means we're starting at this point on our graph to move upward, our period, or at least the value to adjust our period, and then phase shift to the right by pi over 6, midline of negative 3.5. Alright, for cosine, I'm going to just erase that out so I can see cosine easily. Right at that point. Now cosine, there's two ways we can go about this. We could start at negative cosine. So we could use negative cosine and think of this shift to the left of pi over 6. Or if you want cosine to start here, we can use that value and think of this shift to the right by 1, 2, 3 pi over 6. So pi over 2. Let's go ahead and do this shift to the right so we don't need to deal with negative cosine, but if they asked for a negative cosine case, that's what we would do. We would focus on that point there. So I'm going to focus on this coordinate and the fact that if we had cosine, we would be starting at the maximum there. So what we have is we picked up that point, or we really picked up the graph, and we have this phase shift, and we moved it to the right by pi over 2. And again, I counted that in terms of units of pi over 6. 1, 2, 3 pi over 6, which is pi over 2. So, for cosine, we'd have y equals same amplitude. We're now using cosine. In parentheses, same value for b. And now we're doing x. It's a shift to the right, so it'd be subtraction by pi over 2. Close those parentheses all up, and then midline of negative 3.5. So, cosine and sine work with both of those functions. It's just a difference between the phase shift of where they're landing in terms of where they're beginning. We can work with both of the functions to make the same graph.